In fusion welding, you place two pieces of metal together and melt the edges with an oxyacetylene flame. The molten metal from the two pieces flows together and forms a single solid piece of metal. Welding rod is usually added to strengthen the joint. Light gauge steel is any sheet steel less than 11 gauge or 1/8 inch in thickness. You can make many useful articles when you learn to weld light gauge steel. For your first lesson, start by melting a narrow strip, we call it laying a bead, on a piece of 16 gauge sheet metal. Use a small welding tip and adjust the flame to neutral. As you know, the flame is neutral when the acetylene feather just disappears. Start at the right end of the sheet. Hold the inner cone of the flame steady, about 1/8 of an inch above the surface, until a pool of molten metal about 1/4 of an inch in diameter is formed. Hold the blowpipe tip at an angle of 45 degrees and point the flame in the direction you are going to weld. Move the blowpipe so as to make a series of overlapping ovals. The actual oval is very small. This drawing is enlarged so that you can see it better. You will soon learn to recognize the proper speed required to make a good weld. A puddle which is moved at the proper rate shows an even ripple effect of uniform width after it solidifies. Lay another bead, moving the puddle more slowly. Watch it carefully so that you can recognize the signs when it is about to burn through the sheet. Notice that the puddle becomes wider as you reduce speed. Lay a third bead, moving the blowpipe forward faster than you should. As you see, this results in insufficient melting of the metal. Learn to recognize the results of incorrect speeds so that you will know how to control the puddle more accurately. Now start another practice piece, and this time use welding rod to build up the weld bead slightly higher than the surface of the sheet. As before, heat a spot about 1/4 of an inch in diameter until the metal starts to melt. Then lower the end of the welding rod into the puddle to add some of the rod metal. Here are the motions of the rod and blowpipe as you move the puddle along. Notice the circular motion of the flame and the up and down motion of the rod. Continue adding rod metal and moving the puddle to your left. Control the size of the puddle by adjusting your speed as you did on the last sheet. Try for uniform width and evenly spaced ripples. Practice until you can lay an even bead across the sheet. Now you're ready to make a butt weld. In this step, you move the molten puddle along the edges of two pieces of light gauge steel, thus welding them together. First, space the sheets about 1/16 of an inch apart at the starting end and about 1/8 of an inch apart at the other. This allows for expansion of the metal, which we'll discuss later. Make a small weld at each end to hold the sheets in position. We call these tack welds. Now remelt the first tack until its forward edge and the edges of the steel sheets are molten. Then add rod metal to build up the joint slightly above the surface of the sheets. Melt the edges evenly before the puddle is allowed to flow ahead, so that the edges will fuse with the weld puddle. Use the same blowpipe and rod motions learned in the last exercise to move the molten puddle to the left. Preheat the rod by keeping it in the outer envelope of the flame. To ensure a strong weld, melt the sheets to the bottom of the joint, adding rod metal as you move along. Control your speed as necessary to keep the puddle size constant. This weld looks good. It's uniform in width and has fairly even ripples. Let's look at the back of it. Yes, the weld has penetrated right to the bottom of the joint. But a strong weld is even more important than a good-looking weld. Test its strength by bending the sheet like this, close to the line of weld. Keep the bottom of the weld on the outside of the bend. Then squeeze the two ends together. If no cracks appear in the weld metal, you know you have a good weld. You've just made a butt weld. Now try a different type, a flange weld. The end of each sheet has been turned over to form a flange. No welding rod is used here because these flanges melt down to provide all the weld metal necessary. Hold the flame steady until the flanges melt and flow together to make a tack weld at each end. Then melt the first tack and move the puddle along the seam. Make sure that the flanges melt and fuse at all times. The metal furnished by the flanges results in a built-up surface with good reinforcement. Test the flange weld for strength as you did the butt weld. This is a common type of corner weld. Where these two pieces of sheet metal come together, a V is formed which must be filled in with welding rod metal. Tack weld the sheets at each end to hold them in position. Make the corner weld as you did the butt weld. Melt the edges of both sheets before the molten puddle is allowed to flow ahead. Hold the blowpipe and welding rod at angles of 45 degrees. Use the same blowpipe and rod motions that you used in making a butt weld. With practice, you'll learn to make a corner weld using very little additional metal or even no rod metal at all. Test a corner weld by bending the sheet flat and then folding it farther to place a strain on the bottom of the weld. Here is a butt weld purposely made without spacing the sheets. See how the welding heat has forced one sheet over the other before the weld was completed? Such effects of expansion and contraction can be controlled or prevented by the use of relatively simple fixtures called jigs. For flat welding, use a grooved base plate of heavier metal. Place the sheets to be welded on it with a seam over the groove. Next, bevel two pieces of 1/4 to 1/2 inch steel plate at a 45-degree angle and clamp them to the base plate with a workpiece in between. Tack weld each end of the sheets as you did before. Welding jigs for sheet metal are designed to do two things: to act as chill blocks to remove heat from the metal being welded and to hold the pieces of sheet metal firmly in position. Notice how flat and free from distortion this is. It was a lot easier to weld, too. Corner welds can be made at any desired angle by using an appropriate fixture. You can make a simple jig for 90-degree corner welds from a piece of angle iron with a groove cut in the outer corner. Clamp the workpieces between the angle iron and the chill blocks as in flat welding. These jigs illustrate the principle of the use of clamps and chill blocks to control expansion and contraction of sheet metal. You've learned the fundamentals of light gauge or sheet metal welding. Let's review the main points. Use a small welding tip and a neutral flame. For butt welds, space the sheets to allow for expansion and contraction. Add welding rod metal to build up the joint. Melt both edges of the sheets before allowing the molten puddle to flow ahead. For flange welds, place the flanged or turned up edges of the metal together. No welding rod is needed. Always melt the flanges until the metal flows together to assure a strong weld. To avoid distortion, use a jig to absorb heat and hold the sheets flat. Practice until you can make welds that are both strong and neat in appearance. Make butt welds, flange welds, and corner welds in different thicknesses of metal. You'll be surprised how quickly you can learn to make strong, leak-proof welds in light-gauge steel by Oxyacetylene fusion welding.